Lesson 3.3, what we're going to be doing today is we are combining what we've learned in lesson 3.1 and 3.2, and we're solving multi-step equations, okay? That means we've got multiple steps that we have to do in order to solve for the variable. So before we do that, okay, let's review lesson 3.1 and 3.2. So I want you to go ahead and write these down, and we are going to solve them together. All right, so the first problem, Coral, what am I going to do first?
Hold on. I'm still writing on the other one.
Okay. Who can help her out? Josiah, what would you do first?
You would figure out what 5 is, which is positive, so therefore you'd subtract on both sides.
Very good. We're going to subtract 5 on both sides. And he said the reason that we know that is because 5 is a positive number, or it's being added, okay? What happens here is that cancels out. So the only thing I'm left with on that first side is the x. That's exactly what I want. What's negative 12 plus negative 5? Negative 17. Same signs, add and keep. So here's our answer. Now, again, you can check. You can know exactly if you got the right answer. Plug that back in. Negative 17 plus 5. Plug it into your calculator, press enter, and it should tell you it equals negative 12, which is exactly what we have. So we know we did it correctly, okay? Next problem here. Jared, what am I going to do?
You're going to add 9.
Very good. How did you know to add 9?
I don't know how to do it.
Okay, but why? Because 9 is being subtracted, or it's not technically being subtracted. It's a negative number, right? So we just add 9. And what does y equal?
9. 20.
20. Very good. 20. Again, plug it back in and check. Negative 9 plus 20 is 11. So I know I did it right. I don't have to wonder, oh, what grade what grade did I get on this assignment or quiz or test? You can check it. You can know. Now, on this next problem here, Naeem, what am I going to do? Add 4 to both sides. Perfect. Why didn't I subtract 6? Michael?
You're supposed to take it away from the side of the variable.
Exactly. We have to take the number away from the side of the variable. So now I have 10 is equal to z. Is that an okay way to write my answer? No, we just want to write z is equal to 10. Okay, now 3.2, we learned multiplication and division. So what am I going to do in this first example? Dion?
Divide by 5.
Divide by 5, perfect. And he knows that because it's 5 times x, so we do the opposite. What's negative 10 divided by 5? Negative 2. Do not forget, we have one negative sign, so our answer has got to be negative. All right, JT, look at this next one. Y divided by 3 equals 11. So what am I going to do to get y by itself? If it's y divided by 3, what's the inverse of division? Multiplication. So what am I going to multiply by? What's on the same side as the variable? 3. Perfect. So I multiply by 3. What happens there is it cancels out. I multiply by 3 on the other side, and I get y is equal to what? 33. Perfect. Plug it back in. 33 divided by 3 equals 11. I know I got the right answer. Now on this next one, let's see here. Let's see who knows how to do this one. Christian, what would I do? Multiply by the reciprocal. Perfect. Anytime you see a fraction in front of a variable, we multiply by the reciprocal. What's the reciprocal of 2/3? 3 over 2. Cancel out. I multiply this side by 3 over 2. Now I'm going to write negative 4 over 1. Do you see anything that I can simplify before I ever multiply, Dion?
Negative 4 and 2.
Very good. What number goes into both of these?
1 and
Well, 2 goes into 2 one time. 2 goes into negative 4 negative 2 times. And then I know that negative 2 over 1 is basically negative 2. 3 over 1 is basically 3. So negative 2 times 3 is
Negative 6.
negative 6. Okay, so those lessons, what we covered, are extremely important that you understand them for what we're about to do. Because basically, all that we're doing is we're taking both 3.1 and 3.2 and we're putting them into one problem. So we've got to solve for the variable. But before I do that, here's something that I want you to write down, because if you can get this, you'll understand how to solve multi-step equations. It becomes very simple after that. Number 1, you got to know what like terms are. Number 2, I always combine them first. Always combine like terms first. Everybody write this statement down. Always combine like terms first. So for instance, if I were to give you a problem that looks like this, let's say 2x plus 6 equals negative 12. Okay? Do you see any like terms in this problem? Yes. Just because you say, oh, but there's no other x's, so there's not like terms. Can regular numbers be like terms? Yes, they can. Constants right here. Okay? Are they on the same side of the equation? No. So in order to combine them, I've got to do inverse. So I say, okay, I'm just going to subtract 6 on both sides. I've always got to combine like terms first, and like terms can be just regular numbers, or we call them constants. So I get 2x is equal to, what's negative 12 plus negative 6? Negative 18. Now what would you do to solve it? Divide by 2. And x is equal to negative 9. Okay? So you always have to combine like terms first. Here's another little helpful hint, kind of a little shortcut. Okay? Anytime at all you do or you see addition or subtraction, you always do that first. Did everybody hear that? You always do addition or subtraction before multiplication or division. It is the opposite of order of operations. We work backwards, basically. So in this case, addition and subtraction are always done before multiplication and division. Okay? So that's another way to remember it. Here's another little helpful hint here. Remember, like I just showed you, like terms can be on both sides of the equation. So for instance, we had 6 and negative 12. So in order to get them together, I had to do inverse because they were on opposite sides of the equation. Sometimes they can be on the same side of the equation, okay? Like terms can be anywhere, and we always want to combine them when? When do I combine like terms? First, thank you. Okay, so here we go. Let's get into it. Go ahead and write these problems down. Okay, on the first problem here, let's look for like terms because I know I've got to combine them first. Does anybody see like terms? Michael?
Negative 5 and 10.
Negative 5 and 10, perfect. Are they on the same side of the equation? No. So what do I got to do to combine them? Add 5 to both sides, perfect. You say, well, wait a second, why couldn't I just subtract 10? Why can't you subtract 10? Exactly. I'm trying to get x by itself, which means I got to start eliminating things on the same side of x. Also, if I were to subtract 10, what would I be left with on that right side of the equation? Nothing. And you can't ever have nothing over there. So 5x is equal to 15. Now what am I going to do? Divide by 5. And x is equal to 3. Does everybody see how we did addition before multiplication? You cannot look at that and go, oh, I need to divide by 5. Your answer is going to be wrong. You cannot work it like that, okay? So look at this next problem. Does anybody see like terms?
Yeah,
What are they?
20 and 60.
20 and 62. In order to combine them, are they on the same side of the equation?
No.
No, so I do inverse, which means I what, Josh Center? Okay, opposite, which is going to be? No, I'm sorry, right here. This. Subtract 20, perfect, on both sides. Now, do I need to subtract 20 from 6x? No, I can't. They're not like terms, so you don't do that. 6x is equal to what?
42.
42. Now what would I do?
Well, that's it.
Divide by 6. What does x equal?
7.
7. Here's another great thing about these problems. Can you check them?
Yeah.
Absolutely. 6 times 7 is 42, plus 20 is 62. Yep, I know I got the right answer. Okay, look at this next one. People say, oh, fractions, nope, I'm skipping it. I'll just take the points off. No, it's going to be so easy. Watch what we do. First of all, do I have any like terms?
Yes.
Yes. So what am I going to do? Add 5 because I know negative 5 and 10 are my like terms. So I have 1/2 x is equal to 15. What do I do when I have a fraction in front of my variable? Multiply by the reciprocal. What's the reciprocal of 1/2? 2, or 2 over 1. Oh, that becomes really easy. Because what's 15 times 2? Can I do that?
30.
Yep, 30. Then you could plug it in. 1/2 times 30 is 15, minus 5 is 10. Yep, I know I got the right answer. Okay? So example 2. We've got more like terms than we had on the last one. How many sets of like terms do I have in this problem? Michael? 2. What are my like terms? Somebody tell me one set. Talisha?
7x and 3x.
Okay, perfect. 7x and negative 3x. What is my other set, Jordan?
8 and 24.
Negative 8 and 24. Now, let's combine. Guess what? It does not matter which ones you combine first, as long as you combine them. So you can say, oh, I want to add 8 to both sides first. And then somebody else may say, oh, I want to do 7 minus 3x first. Guess what? You're going to get the same answer, as long as you both do the math correctly. So I like to add the like terms that are on the same side together first. Because do I need to do inverse for 7x minus 3x? No, because they're on the same side. So what's 7x minus 3x?
4x.
4x. Minus 8 equals 24. Now I can't forget, I still got these like terms. So Alex, what am I going to do here?
You're gonna add 8 and 4.
Perfect. Now on this instance, I do have to do inverse because they're on opposite sides of the equation. So now I have 4x is equal to what? 32. Now my last step is to divide by 4. And x is equal to 8. Does everybody see how you always combine like terms first, which means I'm always adding and subtracting before I ever multiply? Look at this next problem here. How many like terms do I have? 3. I've got one set, but there are 3 different like terms, okay? That means, which ones am I going to combine together first? Michael?
The ones that I said there.
Exactly. The ones that are on the same side together. You always want to do that first. In this instance, it does matter, okay? 2y, and then what's 10 minus 7?
Negative 3. Or 2.
Positive.
Positive 3, different signs, subtract and take. Now I can do 3 equals negative 5. So what am I going to do to the 3 to move it over? JT? Subtract, perfect. Now I've got same sign, so I add and keep. What's negative 5 plus negative 3?
Negative 8.
Negative 8. Then I divide by 2. And remember, don't forget about your rules for negative and positive numbers. What is my answer going to be? Negative 4. One negative sign, so I know my answer has to be negative. Okay, now look at this next problem here. 2/5 x minus 1/5 x plus 9 equals negative 1. Do I have like terms?
Yes.
Yes. What are those like terms? 2/5 x and negative 1/5 x. What else? Positive 9 and negative 1. So let's combine the ones that are on the same side together. Guess what? They were so nice to me. Do I already have common denominators? Yes. So what's basically 2 minus 1? 1. So I have 1/5, because remember, whenever you have a common denominator, you always keep it. I have 1/5 x plus 9 equals negative 1. What am I going to do now? Subtract 9, because I've still got some like terms to combine. And I have 1/5 x equals, what's negative 1 minus 9? Negative 10. Same signs, add and keep. How do I get the x by itself? Multiply by the reciprocal, which is 5/1. Or technically 5. So what does x equal? Negative 50. Again, you can plug that in and check, and you would get the final answer. Okay? This is where, or I'm going to go ahead and have you try these on your own, but this is where we're going to stop with part 1 of 3.3 today. Okay? We're going to do the rest of it tomorrow, but I want you to go ahead and write these down and try them on your own. Okay, so let's work on these, or I want you to tell me what you did first. JT, on this first problem here, what did you do?
I did minus 12. Minus 12 on the other side.
Perfect. He subtracted 12 on both sides. So now we have 3x is equal to what? Negative 36. Okay, Kim, what did you do now? Perfect. Divide by 3 on both sides. And what does x equal? What kind of 12? Negative 12. Very good. Okay. Let's see here. Dylan, what did you do first on this next problem?
Combine 5x and negative 6x.
Very good. Combine 5x and negative 6x, which gives me what?
Negative 1x.
Perfect. Negative 1x. Different signs, subtract and take. Okay. Alex, what do I do next?
You subtract 10 from 15.
Very good. Subtract 10 on. Once I subtract 10 on both sides, I've got negative 1x equals what? 5. Then I divide by negative 1. You always want to divide by whatever is in front of the x. And what does x equal? Negative 5. Very good.
So you subtract 10, you don't add it?
Right, because 10 is being added, so I have to subtract it. I do the opposite. Yep. It's negative 5. Okay. Michaela, what did you do first on this last problem? Perfect. You subtract 7 because I've got to combine like terms first. And then I have 1/3 x is equal to what?
2.
What kind of 2? Negative 2. Then what am I going to do? Multiply by the reciprocal, which is just 3/1. So I multiply by 3 over here. And x is equal to negative 6. Okay? That's how we do our first part of solving multi-step equations.